Hi everyone, my name is Sebastian Sosa. I'm a junior researcher and the main leader of Animal Network Toolkit software, an R package that allows you to realize hypothesis testing of animal social networks. Today I will show you a second R package I developed on my own, NetExplorer, a package that allows you to visualize and explore networks. The package is still in development, so if you find any bug or if you have any suggestion for improvement, please contact me through the GitHub page. The link will be in the description section below the video. While the package is still in development, I believe that the current stage of the package will allow you to realize pretty good stuff, and the purpose of the video of today is to show you what you can do with NetExplorer. So first of all, you will need to install it. The procedure to install it is also in the GitHub page, as for the moment the package is not yet on CRUN. However, I applied for it, so it should be available soon. And once it is, you should be able to install it through the normal R procedure. So once you install NetExplorer, you can go to your R environment and call the library, set up your working directory, and you will need to import two objects. The first one is a square matrix that represents a node connection. It can be individual interaction or individual association. The second object is a data frame that gathers individual characteristics. For the video of today, I will use a part of my PhD work in which I collected friendly social interaction in Barbary macaques, a non-primate species, and more specifically, allogrooming behaviors between individuals. I will also use ant library to quickly compute individual strengths, degree, and eigenvector. Those have been added automatically to my data frame, and then I will be able to use the only function that is currently available on NetExplorer. In this function, you will need to specify four mandatory arguments. The first one is a data frame, the second one is a matrix. Then you will need to specify the column in your data frame that gather individual identities. Then the column in your data frame that will specify the node size differences within your network. For the video of today, I will specify strengths, individual strengths as the size of my nodes, individual age as the color of my nodes with a gradient going from red to blue, node shape as is specified with individual sex, with males being triangle and females being circles. I will specify node border or node stroke according to individual hierarchical rank, computed with the David score, and the border color of my nodes with individual eigenvector centrality with a gradient going from green to yellow. I also specify layers according to individual sex that will allow me in further to gather individual according to these characteristics. Once you specify all the arguments of the function, the mandatory and the optional ones, you can launch the function that will open your default web browser. So you will end up first with a quite messy graph, but with the option at hand, you will be able to better visualize it. And I will show you how I proceed. So first of all, I start to increase distances between nodes to better visualize them. I recommend to use the text field to have a better control of the option values. Then you can proceed in a similar way to change node size, border width, decrease or increase label size, change links width, increase or decrease link opacity, change links curve, and change the color background. I usually use neutral gray because it allows me to better visualize the color gradient between my links. Once you are happy with your network, you can start to explore it. And to do that, NetExplorer allows you to have a pop-up that appears when you put your mouse over a node. It will highlight its characteristics as well as its direct connection with other nodes in the network. And this is how NetExplorer allows you to quickly visualize extreme values and potential outliers. Now we can finish by looking at the different layouts that are available on NetExplorer. So we have the default one, that is force layout, circular layout, and as you can see, each time you declare a new layout, you will need to specify the option again. The second layout is linear layout, and both circular and linear layout are organizing nodes according to the size you specify within the network function. And finally, we have the multi-layer layout. So this multi-layer positions the node on different vertical levels according to the variable stated in the air function. This layout is experimental and reorganize the node according to their current node position. So this is why I use linear layout first to line them up so they are placed on the same horizontal level and organized according to their size. I also artificially increase the distance between the nodes to keep this structure, this organization according to node size, and then specify the multi-layer. You can see that our nodes are organized according to the size within the layer. We can modify the node size to have a better look at it. Increase links width. And you can see that this layout has specific options, such as vertical spread to reduce, for example, the spread within between the layers. Horizontal spread to modify the spread horizontally. And also specific option according to link opacity. So for example, if I want to focus only on between layers connection, I can remove the links within the layers. Or in contrary, if I want to focus only on links within the layers, I can remove the links, the interlayers links. Finally, we can see here how Network Explorer can allow you to visualize complex information within the network with his pop-ups, but also with the different layouts, because here we have an example in which we can see that females that are at the bottom have larger nodes than males overall, but also that node size, we can observe a kind of gradient going from red to blue that are related to individual age. And this organization with larger nodes in red, so younger individuals, is present in both layouts. So this illustrates how social grooming structure is influenced by both age and sex, as demonstrated in the past research, including mine. To finish additional and minor functionalities, for example, you can move and isolate and pin a node, and of course undo it if you wish. And once you get a graph you want, you can easily save it as an SVG format, which is a vectorial drawing, so there is no resolution loss, and you can resize the graph over and over. Okay, I'm done with this small overview. I still have more functionalities in mind, so I should be back with other videos. Don't hesitate to use the GitHub link to test the package. have a look on my website. And of course, like and share this video. See you soon with more content on social network analysis. Bye.